Hi everyone, this is Rongyue, and this video is for homework 7, question 8. Okay, now let's take a look at this question. It gives us three properties of a Poisson process, and question A asks us to find the expected value of xt. From the previous chapter, we could find that the formula of probability calculation when x equals k. This formula is given, and it is equal to e to the power of minus to the power of negative lambda times lambda to the power of k, divided by the factorial of k. So actually, we know that the expected value of x is equal to lambda, but we could also try to calculate that again. So this is the formula of probability. The sum of this probability from 0 to infinity will equal to 1. So this is equal to 1, right? And we could get that we could time this time e to the power of lambda at both sides of this equation. So the left side will be the sum of this from 0 to infinity, and the right side will be e to the power of lambda. And we could calculate their derivative at both sides. So this will be k times lambda to the power of k minus 1 divided by the factorial of k. The right side will the right side won't change. So again, times lambda at both sides. So the left side will be k times lambda to the power of k divided by k's factorial, and the right side will be lambda times e to the power of lambda. We are trying to construct the formula of ex, right? So we could divide it by e to the power of lambda at both sides again. The left side will become e to the power of negative lambda times k. And the right side will be just lambda, right? So we could say this is actually the formula of the expected value of x. So we could get that ex actually is equal to lambda, right? So ext is equal to lambda times t. And we could also try to conclude some other properties. This is equal to x, the square of x minus eta, right? The expected value of this. So this is equal to actually the expected value of x squared minus eta squared. And the eta square will be lambda squared, right? So this is equal to the expected value of x squared minus lambda squared. So we could also try to find this. Actually, this is equal to, we could use a similar method as this. I will just skip these steps and we could get that it is equal to 1 plus lambda times lambda. Actually, we already calculated this. I remember at previous homework, so I will just skip the process. It's very easy. So also the expected value of xt squared is equal to 1 plus lambda t times lambda t. Right. So this is also easy to find. We could just bring this back to the formula and get that this is also equal to lambda. So this is also lambda t, right? Okay, now let's take a look at question B. Find RT1, T2. We could discuss them in different cases. When T2 is greater or equal to T1. Actually, since the book side, we could get from the definition, Poisson process is an independent increment process. So, which means that xt1 minus x0 will be independent with xt2 minus xt1, right? Those two variables are independent. So actually this will just be xt1 because x0 is 0, right? So we could get that rt1, t2 equals the expected value of xt1, xt2. And we could construct this xt1 times xt2 minus xt1 and plus xt1. Sorry, I will write again in a new page. RT1, T2 is equal to the expected value of xt1, xt2. And this is equal to xt1 times xt2 minus xt1 plus xt1. Because we want to construct two independent variables, so we will use this method. And this is equal to the expected value of xt1 times this xt times this, and so I will just write it as expected value of xt2 minus xt1 plus expected value of xt1 squared. Right, so the previous part is, the former part is equal to lambda t1 times lambda t2 minus lambda t1. Use the previous formula we calculated in question A, right? And plus 1 plus lambda T1 times lambda T1. Right? Also use the former formula. 1 plus lambda T times lambda T, right? And this is equal to lambda times T1 plus lambda T times T1 times T2. So this is RT1 T2 when T2 is greater or equal to T1. We'll assume that. Also, if T1, similarly, if T1 is greater or equal to T2, RT1 T2 equals lambda due to symmetric property T2 plus lambda times T1 T2. Right. So we could write it in one formula. RT1 T2 is equal to, we could say actually the difference happens here. So this is the mean value of T1 and T2, right? So this is lambda times mean T1 T2 plus lambda T1 T2. Right. And that's all. Thank you.